हेलो।
सर जो से अगर
हम्म।
नेगेटिव एक्स की तरफ जाएंगे फ्लो तो प्लेन की डायरेक्शन क्या होगी?
Okay. So, let's say you have this one only, right? So if you are drawing, let's say this is your y coordinate you have drawn in that way that you are taking y positively upward. So that is choice is yours. You can take y plus either upward or y plus in the downward way because that is your way to draw the coordinate. Nobody is forcing you to take the y upward as a plus, right? So let's say this is your y direction you have taken, this is your x direction you have taken. Fine. Now this is the plane. So if you are talking, this is the plane. So if you draw the perpendicular, if fluid is flowing in this side, either this side or that side, fluid flow doesn't matter actually in case of plane. So if fluid either flowing this side, that side, this side, this side, if you will draw the perpendicular, it should perpendicular drawn on that must go within the fluid only. So fluid is here only in this part. So perpendicular if you draw, it will go only in this side. So this is the plane only. So if you are taking this side is plus y, so this is plus y plane. Is that fine? Hello?
यस सर।
So direction of flow doesn't matter in case of direction of plane. Direction of plane means that draw the perpendicular on the plane.
यस सर। यस सर।
It should go within the fluid, and then you think the what direction of that particular coordinate you are taking. If you are taking by this side, so perpendicular on this will also go to plus y, so that is the plus y plane. Suppose you have two confined plane, one is here, one is there, just like this, and fluid is in between of these two. So if you are taking plus y coordinate upward, so the bottom plane is plus y, top plane is minus y, because from top plane the perpendicular will go within the fluid to minus y direction. Okay, is that fine?
यस सर।
Okay. So any other doubt? So we can start. So in the last class we were here. So very good morning to all of you. And in last class we have talked. We were here the pressure at a point, and then we have calculated the forces on that particular plane. So the pressure force is just pressure multiplied by area perpendicular to the point of action of the pressure. Actually, pressure force in that way. So pressure multiplied by area. Now you have just calculated their component in plus x side, means x direction, y direction, z direction. So you wrote the equation for that. And if that particular system is in equilibrium here, then individual component of force in x direction, in y direction, and z direction must be equal to zero actually. Therefore, you wrote the equation here, this one, that is a force balance in direction x. This is force balance in direction z, and there would be force balance in direction y there. So y direction they have not considered because y direction continuously fluid there. Actually, the surfaces are being considered only in the this direction only, x and z only. Okay, and then you have substituted your theta values and all this. So that's what here. So let's say the next part here that we want to drive the equation for pressure. So practically, you might have already taught a long time back the pressure equal to the rho GS, right? That's what, yes or no? So this is just a derivation here that how to come up with that expression actually. So if you are talking about, let's say, a fluid here of that is a differential volume, and this is the differential volume we have taken in the dimension of delta x, delta y, and delta z here. And this is the coordinate the system is being selected here. So this is completely your freedom. So here for this direction is selected at y. Vertical direction is selected plus y plus z is upside, and x is coming to this side perpendicular to this particular slide. Now here, if this particular element of the fluid is at rest, so it means it should have net forces must be equal to zero, right? Yes or no? So
Yes,
that's
sir.
why. So it have the six surfaces because you have taken it just like a cuboid here. So it have the six surfaces here. So one surface is this front side, one surface is back side, one is this side, another one is this side, left, right, top, and bottom. Fine. Just like if you will take actually this book here, so it has the six surfaces here. One is this top one, other one is bottom one. This is this front and back, and this left and right. So it has the six surfaces. So all surfaces would have the surface forces, right? The surfaces would have surface forces, and this particular the entire thing would have its own weight also. So that these would be the components on this particular element, right? Yes or no?
Yes, sir.
So you will have all surface forces, add them up, and all body forces, and because if it is in the rest, so it must be equal to zero. Yes or no? So that's what you have here. Now, let's say you have considered the pressure at the center of this particular cuboid. The center is considered at O. Let's say pressure here is being considered as a P. Now, you want to know that how much pressure would change if you will go from this center to this right side. So right side you are the moving because total the dimension here is delta y here in the slides. So you are at the center, so you want to go half of that. So it dx by 2, right? Dy by 2, sorry. So if you are going this side, because total is y, you are going half of that from the center, so you have moved dy by 2. If you are moving to left side, so you have moved to dy by 2 to the back side only. So that's what you have here at center O. You have considered a pressure. Now this is pressure is just a function here of the distance here. Now you are expanding it with the Taylor series expansion. Do you know this? Have you heard Taylor series expansion?
Yes, sir.
So Taylor series expansion, if you will just calculate only first two term here. So this is your first two term here because at the center the pressure was P. Now you have moved by d by to this side, so you calculate that function derivative with respect to that particular coordinate, multiply by the distance you have moved it, so that is your delta y thing. So delta y here is just dy by 2 only. So first term you want to add, so it's just power 1. If you want to add the second term, just add this power 2, right? That's where you go for Taylor series expansion, right? Correct or not?
Yes, sir.
Yes, sir.
So that's where you went to Taylor series expansion of P in plus y direction. So if you do that plus y direction, this is the first term or first two term only. So you will get this. Now this is the pressure at this particular surface. Sorry. So this is the pressure at this particular the surface. Now you want to calculate the pressure force. So you calculated pressure here. Now you want to multiply the area of this particular the surface. So area here of this surface is dx into dz only. So that's why you have the multiply here dx into dz. So this has become the pressure force now. Now it is acting in minus y direction. So this is minus y direction in case of ij coordinate the system. So you are just putting minus j cap. Is that clear?
Yes, sir.
So it's fine here. First you found pressure here, then you multiply by area. So area of this plane is dx into dz. So that's the now pressure force. Now you want to find the direction of that. So in the this is working on this minus y direction. So it's coordinated minus j cap actually. Okay. Now same thing to the left hand side parts. You calculated pressure here. So this pressure is acting this side on this particular the surface. So you have moved now to minus y sides, minus dy by 2. So therefore you got the pressure here P minus delta P by del P by del y multiply by dy by 2. Dy by 2 is just your delta y, which you have moved only to the left side. Multiply by area of plane. So this plane and this plane are same because you have just considered the rectangular block here, cuboid. So you have multiplied by dx into dz. Now the direction coordinate of this particular force, because force has the direction. So force would be in this side is plus y side. Therefore, you have wrote here j cap. Okay. Say yes or
Yes,
no. At least some किसी
yes,
का
sir.
तो sound आना चाहिए.
Yes,
हाँ.
sir.
Yes, sir. Yes,
Yes.
sir.
Now you want to move to the top plane, top one here. So if you want to move in the figure here, top one. So you are calculating pressure. So top, if you want to move here, you are moving only dz by 2. So at the place of y here, you are now moving into z direction only. So y would be changed by z. So here, this would become now, if you are talking here, the pressure here would become the P plus del P upon del Z into dz by 2. Multiply by area of this plane here. So area of plane of this is this dimension dy and this dimension is dx. So the area would be dx into dy. So that would be the pressure force which is acting in this minus z direction. So you will pay for minus k cap because z coordinate is minus k cap. Same thing in bottom side. So you will put minus sign at mean the everywhere there. Just like this here, you have the left and the right part. So you will have same thing on this. Now talk about the front part. This part here. So this part, the pressure would be this side. So you have pressure. Now you are in x direction. So you will just P plus del P upon del x multiplied by dx by 2. Again, the area of this plane. So this dimension is dz and this dimension is dy. So dx this is dy into dz would be the area. So you got all pressure forces now. Same thing on this side also with the minus sign. So you got the pressure force on the surface. So if it is the and this book would have its own weight. Weight is W, right?
Yes.
Yes, sir.
Weight is जो है W, so weight and W equal to is called mg. So m would be rho into V. Rho is fine. Now you want volume. So volume of this book would be dx into dy into dz, right? Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
So that's what you have on next slide. So this is what you have. The body force is given by this. This is the body force on this. So g vector. So we are taking the g vector here because we want to calculate force in x direction, y direction, and z direction. Because all force component in all direction must be equal to 0. Therefore, we have put a vector sign here actually. So g vector and dm. So dm is this rho into this dv. So this b symbol is just for volume only. Inverter v with this sign is called the volume only here. The volume for this would be dx into dy into dz. So that's what it would be your body force actually, rho g vector dx dy dz. Now let's say the pressure forces here. So if you are talking about the pressure force, this is L. I just put here. This you are just calculating the pressure here. So just put L for left part here only. So here you just calculate it here. So this YL delta y, and finally you got from Taylor series expansion here this one, that P minus del P upon del y into dy by 2. So you are on this side only. Now same thing can be calculated for the right side one here. So right side one would be the P del P upon del y dy by 2. This is for top, the pressure on top surface. This is pressure on bottom because you went to minus dz by 2. This is front here, so you came to this side dx by 2. This is back side, you went back side by dx by 2. So therefore you have the minus 1 here. All higher order term has been cancelled, considering that this dx itself is very low, so that power of 2 factor would be the in such a way that that particular term value would be the negligible only. So therefore, we have not considered the higher order terms in that. Now we want to add now the forces. So here we did the df vector here as we put surface only. So as symbol here for the surface, all surfaces forces on this particular differential element. Therefore, we put here d symbol here, differential sign. So this is for your left side multiplied by area is the direction was this side. Therefore, you kept I cap. This is uh, uh, no, this was your this one actually back side. Now you have this front side because front side this coordinate we have considered x here. So you have multiply again the area here. So if you are in this side, your direction is this minus I cap here because in that case the plane is this side. Same thing is for y. Y you have taken left and the right one here. So therefore you have here the left side is the minus dy by 2. Right side was dy by 2 multiplied by area of this particular plane. So this coordinate you have considered one coordinate was z and this coordinate was considered x only. So therefore you have here the area here dx into dz. Now you have this top plane here. So this is bottom plane actually because you came down. So this force will act this side and direction of this would be that k side only. So therefore you have here k cap. If you are talking about top, the pressure force would act this side. So direction would be here the minus k cap. Is that fine? Is this slide okay? All the components?
Yes, sir.
Mhm. Now you have all surface forces. So you can add them up here. So if you add them up, some common term will get cancelled. This P and this P will get cancelled. Here you have half here, here you have half, here you have minus sign, here you minus sign. So these would be added and it will become full, right? So if you add them up, you will ended up with this equation here because here this and this would be added and total would be with minus sign because this also have minus term, this also have minus term. So you will get del P upon the del X into how much? Dx only because dx by 2 and dx by 2 now it will become full dx. And that dx has been taken as a common here because each term would have dx, dy, dz. Here also you have dy, dx, dz. In this term also you have dz, dx, dy. So this common dx, dy, dz is common in all terms. So therefore that has been taken as a common here. So from first line, you will get del P upon del X into dx, dy, dz, I cap with minus sign. Fine. From this second line, you will get here del P upon del Y into dy into dx into dz here with minus j cap because here you have the minus sign, here you have the minus sign, so it would be minus here. Third term here also you have del P upon del Z dz, dx, dy and multiply by this k cap with this minus sign. So if you will just take the common of those, you will come up with this equation here. All surface forces dfx equal to minus del p upon del x I cap, del p upon del y j cap, del p upon del z k cap and multiply by del x, del y, del z. So what is this del x, del y, del z?
Volume.
Volume, right? Now we want to do the total force balance on that. So total force case, we have just put total here. We have not put here surface. We have not put here body. We have just put here total F, only F here. So total surface force on this particular system here for time being, because it is the rest here, so it will have the surface forces, all the surface जो भी force आप जहाँ लगा रहे हैं, then all body force. So body force is weight only. So therefore you have added all. So here you got this sum that gradient sign here, the gradient of P. So the previous expression you have here. So this is called this particular expression, entire thing, the whole term here, del P upon del X I cap, del P upon del Y J cap, del P upon del Z K cap. This is called gradient of P only. Fine. Gradient is known to you already, right? Gradient just your the trigonometry is being taught to you as a slope, and that also I call the gradient just del upon del x of anything, derivative of anything. Fine. So therefore, you have here the gradient sign here, the gradient of P plus this is from body force component. You have there rho g into volume only, right? Now the volume was common in both the terms here. Therefore, you have taken here df upon dv this side. So this side here you have gradient of P and this one rho g. Now you can have Newton's second law of what does it say? What is the Newton's the second law?
Force is equal to mass into acceleration.
Right, that's what you have here. So you have here that once it is the rest here, so you should not have any acceleration also, right? So this is your force, total force dF. This is rho into delta V is called mass only. This is acceleration. So you have taken this volume to the denominator side. So if fluid or any body in the rest, so its acceleration must be equal to zero. Volume cannot be zero. Force may or may not be zero, and density cannot be zero. So only thing you are forcing is acceleration can be zero. Therefore, this you are getting equal to zero. Okay. So this
Yes, sir.
condition has to be applied the total force which you have calculated previously. So you have calculated total force is this this the gradient of P plus rho g equal to your total force was there dF upon dV was there. So therefore from this second law this is equal to zero here. Fine. So this is
Yes,
called
sir.
del. So
Yes,
here
sir.
so now you can elaborate this in terms of words now. So if you want to write this particular term, this is called net pressure force per unit volume at a point. Okay. This is the net body force per unit volume at a point, and if put it at the rest, both total of both must be equal to zero. Fine.
Yes, sir.
Now you want to write this equation for x direction. If you want to write x direction, what would change here? So at this place, you will write del P upon del X because now you want to fixing the direction only. It will become rho Gx, component of G in direction X, because you cannot say that X direction is always horizontal or always vertical. You can take X direction maybe this side or maybe inclined. So in that way, you will have some component of G in that particular direction. It may be zero or may not be the zero, that you cannot generalize. Therefore, you are putting here the word here rho Gx. So you will just always calculate G cos theta in that particular sign and just substitute the value. If cos theta is 90 in case of this side, so if this direction is x, so your Gx value would be cos 90. G cos 90 would be equal to 0, right? Suppose you want to write for y direction. If you want to write y, so this equation will change minus del p upon del y equal to rho gy. In z direction would be minus del p upon del z plus rho g z. Okay.
Yes, sir.
Uh, Now you want to, so this is what the you get here. So here, if you see the previous one here, this one. So this is the pressure height. So in the previous slide, I think you are taking Z coordinate. The upside you want to calculate only in variation in Z side, because in case of the fluid, the pressure would change with respect to height only, right? Pressure is not the function of this xy plane. It is the function of only in height. So in previous the derivation, we have taken the this coordinate is Z only. Fine. So therefore, we wrote for dP upon dz equal to minus the rho g here. Fine.
Yes, sir.
Uh, Right. So this is your equation for fluid, the static, the pressure variation. Now constraint what you have here, these are the constraint for that. Static fluid, gravity is the only body force, and z axis is vertically upward. These are the constraint for this particular formula. Fine. You can have electromagnetic forces, these forces, and so other forces, nuclear forces. Those are not being considered here. Only gravity is the only body force which are being considered. Fine. Now, let's say here, pressure variation in case of the static fluids. So, we are just considering first the incompressible fluid so that your density should not vary here. So, if you are at this point here, Z equal to 0. So, let's say the pressure at this particular point is P naught. So, if you are coming down in a particular fluid, would the pressure go up or will go down?
Pressure
So
will go up.
Works.
Right.
generally,
As you will go deeper and deeper into the fluid, so the fluid height on this particular surface would be, let's say you have this particular plane. Now this much is the height of fluid, so iska pura weight of this fluid will put the pressure on that, right? Because that much weight of the fluid will act perpendicular to this particular the surface, so it will create that much weight. As you will go more deeper, your weight will become more, therefore the pressure would be more, right? As you will go up and up, your height will keep on the decreasing here from the deepness will decrease. Therefore, your weight of the fluid on this particular the surface would also decrease. Therefore, your pressure would also decrease. So therefore, you have here that if you are going down in a particular fluid, the pressure would increase. If you are going up, your pressure would decrease. Okay. So
yes, so
in P equal to rho GH formula, actually G is H is positive if you are going downward into the fluid, and H would be taken as a negative if you are going upward in the fluid. Fine. Now, that's
yes,
what
so
you have here, that if you want to calculate the pressure variation in the fluid here, so you have P minus P naught equal to the rho GH here. So if you want to calculate P at a particular point, just P naught plus rho GH. Now, H would be plus if you are going down, H would be minus if you are going up. Now, you can have multiple fluids also. So, if you want to have a multiple fluid, just like let's say you have this particular column, and in this you have filled several fluid. Let's say in bottom you have oil, then you have water, then you can have mercury, then you can have the several fluid in a particular column. Just like your distillation column, your density, or let's say the petroleum fractionation column, in a one column you are getting 30 40 actually petrol products. The top product is the gasoline, then you have diesel, then you have this cooking gas, so and then you have kerosene and all this. Then bottom you will get tar. So in one column you have several fluids of different densities. Now you want to calculate the pressure variation in that particular column. So you have the variation in density also and H also. Therefore, here the delta P in a particular thing would be calculated G into summation of rho I Hi, and Hi we have So we were talking here the pressure variation in a particular fluid there. So if you are going down in a fluid, just check H as positive. If you are going up, minus. Within a fluid, there is no change in the density, but if you are changing the fluid, then there would be a density change. Therefore, you have the correlation here, this one here, the delta P, the total pressure variation from here to here would be G multiplied by the summation of rho I HI. If you have, let's say, two fluids, so you will have here G rho 1 H1 plus G rho 2 H2. Fine if you have two fluids within a particular column. If you have three, just multiply by rho 1 G H1 of fluid 1, then rho 1 G H2 of fluid 2, then rho 2 G H3, rho 3 G H3 of fluid 3, and keep on adding only. Simple. Is that fine? Is that fine?
Yes, sir.
Now
Yes, sir.
Yes,
this is
sir.
the example here. Let's say we want to measure the blood pressure. Blood pressure में क्या करता है वो? आपने देखा है जो गांव में या हॉस्पिटल में आप डॉक्टर के पास में जाते हैं, ही मेजर द ब्लड प्रेशर ना.
Yes,
Yes,
sir.
sir.
क्या करता है वो? व्हाट
Yes,
डज ही
sir.
डू?
Yes, sir.
व्हाट डज ही डू?
सर सर वो बाजू पे एक पट्टी टाइप लगा देता है और फिर मतलब उसके
राइट.
पास कोई
फिर उसको प्रेशराइज करता
कंप्रेसर
है,
टाइप
जो हम
होता
पंप
है।
टाइप
बबल
एक
से
मारता
यस
राइट,
है
सर,
डायरेक्ट
प्रेशराइज
वो।
करता है।
बबल से
हाँ,
प्रेशराइज
यस सर।
करता है. उसके बाद उसके यहाँ पे
यस
एक
सर।
वो ट्यूब लगा होता है, उसमें वो जो मैनोमीटर की हाइट रीड
हाँ,
करता
हाँ।
है. राइट. तो ये वही है पूरा.
यस
ये
सर।
आपका जो ब्लड प्रेशर में आपके जो बाजू में टाइट कर दिया ये वाला एंड. नाउ हियर मर्करी इज फ्लोइंग इनटू दैट पर्टिकुलर कॉलम देयर जस्ट टू मेजर द प्रेशर ऑफ योर ब्लड. ठीक है. सो यहाँ पे ये दिखा है कि नॉर्मल ब्लड प्रेशर फॉर द ह्यूमन इज द हाईएस्ट इज 120 mg of H, mean the mm of the Hg, and lowest pressure is 80 mm Hg. So if you are more than 120, you are hyper pressure, and low is very low pressure actually. So both are not advisable. Now we want to convert these values into absolute pressure. Now my question is that we want to calculate here that if I am here at this particular point, hello, suppose I want to
Yes.
calculate pressure here.
Yes.
Yes, sir.
Suppose you have the air in this particular tube. यहाँ पे जो है जैसा लिखा है, just like that you have air here, right? Okay. Will this air have different pressure from here to here in this particular section?
Yes, sir.
Yes, sir.
क्यों सर, कैन यू
No, sir.
रिपीट योर क्वेश्चन?
If you are filled the air, you have this particular limbs, the left limb on top, you have air
यस सर।
from here to here. Will the pressure at this point on top or this one and this one or this one till the point A, would the pressure vary from from your arm till here or not?
Yes, sir. Very.
Yes, sir.
No.
It will be.
यस
No, sir.
Sir, I
In
don't
Would
know.
no,
And
sir.
case,
No, sir. No, sir. It will be the atmospheric pressure.
no, sir.
no, no,
It is
no.
open to the atmosphere.
No, no, it's not open, it is tightened on that, but you have the air in between of two. So the problem here is that
Sir,
if you are
sir,
confining, हाँ बोलिए, if you are
sir, pressure
confining
same.
a, हाँ pressure would be same, that's right. Because if you are confining a gas in a particular column of a very low height or medium height, pressure inside the gas cylinder or container doesn't change with respect to either you go to this side or that side. Because pressure is same in that way. Okay. So in case of gaseous columns of very low height, something pressure doesn't change. Okay. Because the
सर बट
huh, because the in case of gases, pressure acts only because of collision of gas molecules only on the walls, not due to the height. Okay.
Yes, sir.
But in case of very tall columns,
Yes, sir.
just like the atmosphere, you are moving in kilometers, so your height has been changed significantly, and your density has been changed only because your temperature variation there. Therefore, you will have some variation of pressure there. Therefore, your ear pop up when you will take the lift in your aeroplane. In ground floor, you have high pressure. Suddenly, you went up to a kilometers of height. So pressure varies inside the aeroplane due to the elevation change too much or density change too much, and your ear pops out and you feel pain. So in case of very high kilometers, density change, therefore pressure change, but not in very low heights. So here you can calculate pressure at this particular point PA. Now let's say I want to move to this point B. इस पॉइंट पे पहुंचना है मुझे. I want to calculate the how much pressure the difference between point A and point B. So I would start from here. So I would start. So my route is just to actually go from here to here and move to an entire fluid and reach it till this particular point. That way only I can come. Yes or no?
Yes, sir.
Yes, sir.
So there's a rule here. So if you are coming here this way and thus moving up that way, so you are just moving within same fluid. So this much pressure would be, let's say, up here. If you are going further, this much pressure would be more. Now, if you are going further up, then pressure would decrease because you are moving in the same fluid. So if you can directly go from here to this point because you are in the same fluid here because Hg is here throughout. So within the fluid you can move horizontally, just like you are in a tank, bathing tank. Actually you are in a tank there. So if you are at a particular height here, so either you move this side or that side, pressure doesn't change on your neck. Yes or no?
Yes, sir.
So
Yes, sir.
Yes,
within a same fluid, you can move horizontally without any change in pressure. But if you are going down and all, down and up, the pressure would change. So from here, you can directly come at this particular point. So this point is being noted at A dash. So here pressure would be same as of A. Now from here, you want to just reach to B point. So B point is just H distance up. So you are going up. So here pressure was PA, you are going up, so you are going minus rho G, this much is the height. And you have reached to the point B, so that pressure would be also minus B and that must be equal to 0 because this limb is not fluctuating now. So this fluid is now at rest also. Is that fine?
Yes, sir.
So in that case, you will have so pressure equation would become in that case would be your P A minus of rho G H because that much you went up minus of B should be equal to 0. Fine. Now these pressures you can convert into the kilopascal. So how much the pressure formula is rho G H. You have the value of H, you multiply by density of the mercury 13.6 10 to the power 3 multiplied by G 9.8, so you can convert them into the pascals. So divide by 1000, you will get kilopascal. Fine. Okay.
Yes, sir.
yes, sir.
So we will
Yes, sir.
end this thing the here now.